Electron affinity. Electron affinity is another important periodic property of elements. Electron affinity is the amount of energy that is released when an electron is added to an isolated neutral gaseous atom. Electron affinity is the amount of energy that is released when an electron is added to an isolated neutral gaseous atom. Electron affinity is the amount of energy that is released when an electron is added to an isolated neutral gaseous. Add an electron to an atom. It has tendency to accept an electron, then we can add an electron to that atom. When an atom has that tendency, that depends upon the electronic configuration of the atom again, whatever the property it may be. The property of an element or property of an atom belonging to a particular element will depend upon its electronic configuration. So, those elements which are having one or two electrons less than an inert gas in their valency shell have tendency to gain an electron. For such elements, it is easy for us to add an electron. For example, if you take halogens, that is the 17th group, 7th year group elements, where there is a need of one electron to get the octet electronic configuration. For example, if you take, now let us see the electronic configuration of fluorine. Its atomic number is 9. So, its electronic configuration is 1s2, 2s2, 2p5. So, this is the valency shell of fluorine, where you have 2 electrons in 2s orbital and 5 electrons in 2p orbital. Let us verify how these 5 electrons are distributed: p1, p2, p3, p4 and p5. Now, this is the orbital which is having a half filled electron. Now, if another electron was added to it, it will get p6 configuration, that is full filled configuration, which is a stable configuration, and it is equal to electronic configuration of neon. So, fluorine has tendency to accept an electron, provided if other atom is there to donate. So, elements like sodium and magnesium, they have tendency to donate electrons, they lose electrons. If such electrons are available, now this fluorine can take that electron and convert it as F minus ion. Why this negative charge? Because in the nucleus of fluorine we have 9 protons in its nucleus, that is 9 positive charges. In first energy level we have 2 electrons, in second energy level we have 7 electrons. Total 9 negative charges are present in fluorine atom. Now, after adding this electron, the number of electrons that are present in the valence shell will become 8. So that its electronic configuration will become 2s2, 2p6. In such a case, here we have 8 electrons in it, but in the nucleus we have 9 positive charges, but 10 negative charges are there. As a whole, there will be 1 unit negative charge. Because of that, we have this F minus ion. I have this F minus ion. F, when accept one electron, it will give us F minus ion. During the formation of this ion, since it has stability, is getting stability, it releases some energy. It releases some energy. That energy which is released here is called as electron affinity. The quantity of energy that was released when an electron is added to a neutral gaseous atom to form a uninegative ion is said to be electron affinity. This is electron affinity. Now, let us consider the formation of oxide ion. Oxygen atomic number we know. In oxygen atomic number, it is 8. So, its electronic configuration is 1s2, 2s2, 2p4. Here we have 6 electrons in the valence shell of oxygen, but 2 electrons in 2s orbital and 4 electrons in 2p orbital. So, here we have 2 half-filled p orbitals in the valency shell of this oxygen. Now, here also the same thing. Oxygen has tendency to gain 2 electrons. If oxygen accepts 1 electron, it converted into O minus ion in a gaseous state, plus energy is released. So, now this oxide ion, uninegative oxide ion, has tendency to gain another electron also, because it did not get the neon's configuration. So, atom has tendency to attract one more electron, but here nuclear charge is very less. It cannot withhold another electron. So, while adding a second electron to oxide ion to form O minus 2, in this case, instead of releasing energy, energy is absorbed. During the acceptance of second electron by a uninegative ion, energy is absorbed rather than released, as in the first electron's case. Not only for oxygen, for any element, the second electron affinity values are negative. That means, generally in electron affinity, what we will expect? If an atom accepts an electron, energy is released. So, electron affinity is exothermic or exoenergetic. It is exoenergetic only for the first electron, but in the subsequent electrons, instead of releasing energy, energy is absorbed. That is why second electron affinity value is endothermic, minus energy. Energy is absorbed. Not only for oxygen, for any atom, second electron affinity, electron affinity values are endoenergetic. Now, let us verify how this electron affinity changes along the period and along the group. As we move, if you take the periodicity of this electron affinity, periodicity of electron affinity, a long period, as atomic number is increasing, atomic size is decreases, we know. That means valence electrons are more closer to the nucleus. That is why in a period, as we move from left to right, as atomic number is increasing, electron affinity values are increasing because of increase of effective nuclear charge. But in the group, from top to bottom, electron affinities are decreases as atomic number increases, because in any group from top to bottom, the atomic size is gradually increases. But here one exception is there. The first element in any group is very small in size. For example, if you take fluorine, chlorine, bromine, iodine, and actinium. These are said to be halogens. They are 17th group elements. Now, electron affinity values, as we earlierly said, they are decreases as we move from top to bottom. From top to bottom, as we move, electron affinity should decrease. But so that you will expect that fluorine will have more electron affinity value than chlorine. But here, because of small size of fluorine, the electron affinity of fluorine will be less than chlorine. So we can say the trend will be like this. Chlorine will have maximum electron affinity and fluorine will have lesser electron affinity than chlorine. But electronegativity values are more for fluorine, but electron affinity values are of fluorine is less than chlorine because of its very small size. Because of very small size, newly coming electrons will have a repulsion with existing electrons, which prevents the nuclear attraction. That's why it's the electron affinity of fluorine is less than chlorine, though its size is small. When atomic size is less, you will expect more electron affinity, but because of its very small size, the repulsions between the electrons, that is the new electron with the existing electrons, is more because of that repulsions. Because of the smallest size, very small size, fluorine electron affinity values are less than chlorine. So it means in any group, first element will have less electron affinity than the second element. In the rest of the cases, as atomic number is increasing along the group, electron affinity values will gradually decreases. From left to right in the period, electron affinity values are increasing with increasing of atomic number. Whereas in a group, it decreases from top to bottom in a group. This is electron affinity. Electronegativity. Electronegativity is also another important periodic property of elements. The periodic properties which we discussed so far, whether it is atomic size, ionization potential or electron affinities, they are the properties of an individual atom. But this electronegativity is different from them. Electronegativity is a property of an element when it is in the molecular state. In the previous three periodic properties, that is atomic size, ionization potential and electron affinities, are the property of an atom when it is in an isolated state. But here electronegativity, it is the property of an element when it is in the molecular state. When two atoms combine to form a molecule, they bind together with certain bond. So here during the formation of that bond, we have bonds already, covalent bond, ionic bond and all these things. So in that bond formation, when a bond is there between two atoms, definitely one pair of electrons will mutually shared by the two bonded atoms. So both of the bonded atoms, the nuclei of the bonded atoms, will have tendency to attract the bonding pair of electrons towards itself. So the tendency of an atom in a molecule to attract the bonding pair of electrons towards itself is known as electronegativity. What is electronegativity? Electronegativity is the tendency of an atom to attract the bonding pair of electrons towards itself. Let us see one example. Here a molecule, in A2 molecule, two atoms of A will mutually share one pair of electron. In a B2 molecule also, one pair of electron is mutually shared by two bonded atoms. In AB molecule, one pair of electrons, one pair of electrons is mutually shared by between two atoms. Here in the three cases, one is A2 molecule, in which two atoms belonging to an element A are bonded with a covalent bond. In B2 molecule, two atoms of B, the element B is bonded with a covalent bond. And in AB molecule, an atom belonging to element A and another atom belonging to element B is bonded with a covalent bond. In all these three cases, an electron pair was mutually shared by both the bonded atoms. Now, these atoms has tendency to attract the bonding pair of electrons towards itself. That tendency is called as electronegativity. Here in A2 and B2, the two bonded atoms belonging to same element, naturally the tendency of those atoms is same or equal in magnitude. That is why the bonding pair of electron is exactly the center of the nuclei of two bonded atoms. But in the case of molecule AB, automatically when they are belonging to two different elements, we cannot expect the same electronegativity for both the bonded atoms. So, one atom naturally will have more electronegativity than other. It's irrespective of the magnitudes, whatever the magnitude it may be. We are not bothering about the magnitude. One atom will have more electronegativity than the other. So, now in such cases, the element which is having more electronegativity have an edge, and the bonding pair of electrons will move towards this atom, and other atom will have a partial positive charge, and the high electronegative element will have a partial negative charge, and such type of bonds we call it as a polar covalent bonds. We have a detailed discussion regarding these bonds in chemical bonding. Now, the question is, the tendency of an atom to attract the bonding pair of electrons towards itself is known as electronegativity. So, here it is a relative property. The tendency will depend upon the nature of the two bonded atoms, to which side the bonding pair of electron will move. So, likewise ionization potential and electron affinities, here we have no units to express electronegativity because it is a relative property. That is why scientists has taken particularly this Pauling proposed one method to express these electronegativities. Previously before Pauling's expression, Mulliken first proposed to calculate these electroaffinities. Mulliken proposed that electronegativity of an element is an average of electron affinity and ionization potential, because each and every element will have electron affinity and ionization potential. So, electronegativity he considered as an average between ionization potential and electron affinity. But here the question is, we know electron affinity values for only 30 elements. We can calculate the ionization potential values of elements by using discharge tube experiments, but it is not possible to calculate electron affinity values. We can calculate electron affinity values in an indirect manner from Born-Haber cycle. So, it is not possible to calculate electron affinities for all the elements. Only there nearly 119 elements are there, but we know only 30 elements electron affinity values are known to us. So, by taking this as proposed by Mulliken, it is not possible to define electronegativity values also. For that's purpose, Pauling proposed another method which is based on the bonding nature of these bond energies of atoms. He gave one proposal to calculate electron affinities. For that, he has taken a reference element. He has taken hydrogen as a reference element, and he considered the electron affinity value of hydrogen as 2.1. By that way, highly electronegative element is found to be fluorine, and its electron affinity value is considered as 4.0. Hydrogen electron affinity is, electronegativity is 2.1, whereas highest electronegative element is fluorine, its electronegativity value is 4.0. Next to fluorine, the other element is oxygen, which electron negativity value is 3.5, and both chlorine and nitrogen will have 3.0, so that he can calculate so many elements electronegativity values. So, electronegativity is the tendency of an atom to attract the bonding pair of electrons towards itself. It is the property of an atom in a molecule. It is a relative property. That is why it has no units. The tendency of an atom to attract the bonding pair of electrons towards itself is said to be electronegativity. Fluorine has maximum tendency to attract the bonding pair of electrons towards itself. So, its electronegativity value is considered as 4.0. Next to fluorine, the second element, second highest electronegative element is oxygen. Now, periodicity of electronegativity. Electronegativity in a period from left to right, as atomic number is increasing, electronegativity values also increases, because it is related with the atomic size. The atoms which are smaller in size will have more electronegativity. As atomic size is decreasing, electronegativity values will increases. So, in a period from left to right, as atomic number is increasing, atomic size is decreases, that is why electronegativity values will increase. In a group from top to bottom, as atomic number is increasing, atomic size will gradually increases. That is why electronegativity values are decreased if we move from top to bottom in the group. Electronegativity, higher electronegativity values is the characteristic property of non-metals. Higher electronegativities are characteristic properties of non-metal, whereas lower electronegativity values are the characteristic properties of metal. The least electronegativity value is possessed by cesium, which electronegativity value is 0.7. That is the least electronegative element. The nature of the bond will also depend upon the difference of the electronegativity of two bonded atoms. If electronegativity difference is more than 1.9, that bond is considered as an ionic bond. If it is less than 1.9, it is said to be a polar covalent bond. So, this electronegativity values will help us to decide the nature of the bond. Valency. Valency is also another important periodic property of elements. Valency is the bonding capacity of an atom. Valency is the bonding capacity of an atom. The number of bonds that an atom can form is given by its valency. The number of the bonds that an atom can be formed can be given by its valency. So, the bonding capacity of an atom will depend upon electronic configuration once again, because whatever the properties, both physical and chemical properties of an element is mainly depend upon electronic configuration. The electronic configuration of an element will decide the maximum properties of an element. So, here also valency will depend upon its electronic configuration. So, why atoms will form the bonds? We have already discussed in the chemical bond. Atoms will take part into the bonding to get stability, to get the stable inert gas configuration. That was the octet rule. Atoms involved in the bonding to get the octet electronic configuration. So, the valency of an element is mainly depend upon the electronic configuration. Particularly, the unpaired electrons that were present in the valency shell of an atom will be equal to its valency. Let us verify. For example, lithium. Its electronic configuration is 1s2, 2s1. So, this is the valency shell. In the valency shell, you have one electron. Now, beryllium, 1s2, 2s2. That means, here in second energy level, you have 2 electrons in 2s orbital. At the same time, in that energy level, you have empty 2p orbital. Then boron, 1s2, 2s2, 2p1. That is, in 2s orbital, we have 2 electrons, and in 2p orbital, we have 1 electron. Then carbon, 1s2, 2s2, 2p2. That is, this is the valency shell, 2s2, then 2p2. Nitrogen, 1s2, 2s2, 2p3. This is 2s2, 2p3. Then oxygen, 1s2, 2s2, 2p4. Fluorine, 1s2, 2s2, 2p5, 2s2, 2p5. Then neon, 1s2, 2s2, 2p6. So, here if you observe the electronic configuration of neon, here all valency shells are filled with 2 electrons each. There is no half filled orbital in neon. So, neon will not take part into any type of bondings. It will not form any type of bondings. That is why its valency is considered as 0. Now, here if you go for fluorine, fluorine has one half filled electron, half filled orbital, unpaired electron. So, its valency is considered as 1. Here in oxygen, you have 2 unpaired electrons. So, its valency is 2. Here in nitrogen, you have 3 unpaired electrons. So, its valency is 3. Now, carbon has 2 unpaired electrons. So, its valency is 2. Boron has 1 electron, 1. Here there is no electron. You can consider it as 0 and 1. So, these are the number of unpaired electrons that was present in an atom. By default, the valency of any element will be equal to its unpaired electrons. If no unpaired electrons are there, the valency is considered as 0. 0 valency means they will not form any bonds. But here one exception is there. If in the same energy level, when empty orbitals are available, the paired electrons will move into empty orbitals. In such cases, the number of unpaired electrons may increase. For example, if you observe here, here we have empty orbitals, here we have empty orbital, here we have empty orbital. So, in these 3 elements, in the same energy level we have paired electrons. In the same energy level we have paired electrons, and at the same time we have empty orbitals. In such cases, what happens? This pair of electron will uncouple and enter here, so that it will have 2 electrons and its valency will become 2. Here in this case we have only one electron, so its valency is considered as 1. But on extraordinary cases, this electron will move to this side, so that the number of unpaired electrons will become 3. Here also we have an empty orbital, so when this electron enter here, it becomes 4, so it exhibit will 4 valency. In ground state electronic configuration, the number of electrons may be less, but in the same energy level, if empty orbitals are available, these paired electrons will enter into those empty orbitals and another valency is exhibited. That is why the valency of an element is not constant. It is a variable value basing on the atoms which bonded with them. Then also this valency will changes. In general, we can say elements may exhibit different valencies, that we call it as a variability in the valency. They can exhibit variable valencies. The minimum valency of an element is equal to number of unpaired electrons in its ground state electronic configuration. The maximum valency will be the total number of electrons that were present in the valency shell of an atom. The exhibition of maximum valency is not the individual property of an element. It is dependent upon the other element which can bonded with it. It is a multiple nature. So there is no guarantee that it have that maximum valency if maximum number of electrons are there. For example, if you take sulfur, sulfur has 6 electrons in its valency shell, but sulfur can exhibit that 6 valency only when it is bonded with high reactive elements like fluorine and oxygen. It cannot exhibit that higher valency with hydrogen. Because in the ground state of sulfur, if you observe the electronic configuration of sulfur, if you observe the electronic configuration of sulfur, sulfur atomic number is 16. Neon 3s2, 3p4. Here 3d orbital is empty. In 3s orbital we have 2 electrons, and in 3p orbital we have 4 electrons, and here we have an empty d orbital. Now when this electron is go to this excited state, this excited is said to be first excited state. In ground state, it has 2 electrons in its valency shell. In first excited state, 3p3, 3d1. In first excited state, it has 3 electrons in 3p orbital and 1 electron in 3d orbital. Now the number of unpaired electrons, here it is 2, here it is 4. When this electron will also moves, then it will become 3s1, 3p3, 3d2. So in 3s orbital you have 1 electron, in 3p orbital you have 3 electrons, and 3d orbital you will have 2 electrons. Now total 6 electrons are there. So sulfur can exhibit 6 valency also. But that 6 valency is not possible with all elements. Suppose sulfur is combining with hydrogen, it can form only H2S, because these excited states is not possible when it is combining with hydrogen or when it combine with hydrogen to form a compound. These 2 excited states is possible only when it is reacting with high electronegative elements like oxygen and fluorine. With oxygen and fluorine only, SF4, 4 valency, SF6, 6 valency, or SO2, 4 valency, SO3, 6 valency. This 4 and 6 valencies of sulfur is possible only with oxygen and fluorine, but not with hydrogen. So, minimum valency of sulfur is depend upon the number of unpaired electrons in its ground state, and maximum valency is the total number of electrons that are present in the valency shell. In between them you have other oxidation states and other valencies are also. So, this variability of valency is due to the uncoupling of paired electrons or unpairing of paired electrons into an empty orbitals which are present in the nearer same energy level. So, valency of an element is not a constant property, it is a variable property. So, we can say this in the terms of oxidation number also or oxidation state also, because oxidation state of an element will also depend upon its valency. Oxidation number of an element will also depends upon its valency. It is depend upon the number of electrons that are present in the valency shell of an atom. So, the maximum valency or maximum oxidation state of an element is equal to maximum number of electrons that are present in the last energy level, that is the valency shell of an atom. That is why valency, to define valency, we take hydrogen and oxygen as a reference elements. With reference to hydrogen, elements can exhibit minimum valency, and with reference to oxygen, they can exhibit maximum valency. Here hydrogen valency is 1, oxygen valency is 2. So, valency of an element can be defined in terms of hydrogen or in terms of oxygen. If you want to define the valency of an element in terms of hydrogen, you can say that the valency of an element is the number of hydrogens that can combine with one atom of the element to form a compound. The number of hydrogens that can attach to one atom of an element to form a compound is known as its valency. If you want to explain or express the valence in terms of oxygen, valence in terms of oxygen is double to the number of oxygen atoms that are attached to a given atom. Valency is double to the number of atoms that were attached to the atom, one atom of an element is said to be valency. Now, if you want to write the periodicity, valency periodicity is different with hydrogen and oxygen, because with hydrogen it will give minimum valency, with oxygen it will exhibit maximum valency. With respect to hydrogen, valency of an element in a period increased 1 to 4, then again decreased gradually. 4 is the maximum valency with respect of hydrogen. And with respect of oxygen, the valencies are gradually increases equal to their group numbers up to 7, and maximum valency were exhibited by osmium and ruthenium, which are having in the 8th group, which can exhibit 8 valencies also, or 8 oxidations plus 8 oxidation states also. And in a group, all elements in a group will have same electronic configuration. That is why the elements present in a given group will have same valency, since their electronic configurations in their valency shell are same.